All right, calculus. This is the next video. By the time you're watching this video, you should have completed chapter 4, and you should have taken the chapter. What am I talking about? Chapter 5. Okay, chapter 5, and you should have taken the chapter 5 test. So hopefully that went well. So let's go ahead and get started here. Let's get started. This is the title of chapter 6. It's called Differential Equations and Mathematical Modeling. So what we're going to do, I'm going to skip section 6.1 for right now. May come back to it, I may not. I usually skip it. So section 6.2 is where we're going to begin. And so hopefully I have the title of the chapter written. And here is the title of 6.2. It is Antidifferentiation by Substitution. All right. This method is going to be important when we are anti-differentiating a composition of functions. Okay, so if we have a function inside of another function, that's when substitution comes in handy. All right, so let's go ahead and first, I know I've talked about this, the indefinite integral, but we haven't actually defined it. So let me scroll down and have you guys write that down. The indefinite integral, what it is, it's the family of all antiderivatives of a function, f of x. That is the indefinite integral of f with respect to x. And it's denoted, and it's just we just put the integral symbol, okay, the elongated s, of f of x dx. Alright, so notice we don't have an interval, alright, so if we don't have an interval to integrate over, this is what's known as the indefinite integral. Okay, so this is the indefinite integral, and all it is the antiderivative of capital F of x plus c. So that's why it says the family. This c could be anything. All right, we've mentioned this before. This shouldn't be anything new, but that plus c is going to represent some constant that might have been there before we took the derivative. Okay, so if we take the derivative of the antiderivative, we're going to get little f of x. But this is the antiderivative, capital F of x. So if I took the derivative of some function, and then I might have some constant, then when I take the derivative of a constant, that's going to be 0. Okay, so that's why we always have to put a plus c when we anti-differentiate, because we may not have known it was there. Okay, so there might have been some constant that we started with. Okay, so what I'm going to say is, guys, I'm really just going to try to do 2 examples today. Well, not today, but this video. And I'm going to try to keep this video short. Alright, so as short as I can at least. So let's go through these 2 examples. So to get you to kind of think about the a bit of notation, and to get you to think about anti-differentiation using substitution, let's look at this first example. Alright, so go ahead and write this down. Make sure you write this example down and just follow along here. So taking notes while you're doing this. We're going to let f of x equal to x cubed plus 1, and we're going to let u equal x squared. Okay, so what I want to mention here, guys, I just want to go over a couple things. We're going to find a couple of indefinite integrals here. Actually, when I say a couple, I mean 3. Okay, we're going to do 3 of these. So there's going to be a part A, part B, and part C. Okay, so it says find each of the following antiderivatives, and I had to abbreviate it here, antiderivatives, in terms of x. Okay, so let's look at part A, and let's just focus on this real quick. Part A, and this shouldn't take us too long here. And again, if you need to rewind that, pause it here, that might be beneficial. Alright, so let's go through this first example. Just the integral of f of x dx. So guys, we don't need to worry about this function right here. F of x is going to equal x cubed plus 1. Okay, we know what f of x equals. So all I got to do is take the antiderivative of that. Okay, so what is the antiderivative here? Well, the rule that we always use with antiderivatives, we've talked about this. We always, maybe I shouldn't say always, but in a polynomial function or a power function, what we always do in those 2 types of functions is we add 1 to the exponent, divide by the new exponent. That shouldn't be anything new. So when we add 1 to the exponent here, we're going to get x to the 4th. When we divide by the new exponent is 4, so it's x to the 4th over 4. Now, whenever you anti-differentiate a constant, you can just rewrite it as the constant times x. So 1 times x is x. And then what am I forgetting here, guys? Yell it at me. Yeah, that's right, plus c. Okay, so I'm forgetting that plus c. All right, so that right there is going to be my antiderivative. Pretty simple. Okay, so now I want to make some connections here between the integral, the antiderivative of f of x, the antiderivative of f of u, du, and also I want to talk about the antiderivative of f of u dx. Okay, now remember, make sure you say f of u. Okay, that's important, f of u. All right, so let's look at this. So it's the integral of f of u du, if you know what I'm saying. Okay, so here we go. You don't put that of in there, not good. All right, so f of u du, let's talk about this. So all that means is I need to take my u function. So u is equal to x squared, isn't it? All right, so let's look at that first. Well, if u is equal to x squared, okay. Sorry, let me pause here. Let me pause for a second. Okay, let me think about this. Let me make sure I explain this well enough. Whenever you see an f of u du, okay, we know what f of x is, guys. Hopefully everybody knows. F of x is x cubed plus 1. We know that. So guys, if I change the variable here, if I call it f of u instead, well, what would I do to the equation? Well, that just means I need to plug in a u. All right, so guys, the integral of f of u du, all that means is it's going to be the integral of u cubed plus 1 du. Now guys, I want to integrate, so this right here always tells us what variable we want to integrate with respect to. So since we're integrating with respect to u, and since we have u's, we can just go ahead and integrate again. Okay, just go ahead and take the antiderivative. Okay, so what is the antiderivative with respect to u of u cubed plus 1? Well, it's going to be very similar to what we had, except the variable is u. Okay, so we're still going to start out with u to the 4th over 4, just like we did last time. We're going to add 1 to the exponent, divide by the new exponent. So instead of x's, we've got u's. So it's u to the 4th over 4 plus, well, if I want to integrate with respect to u, that 1 becomes, instead of x, it becomes u. Okay, whoops. And then I still have this, what's happening here? Hang on. What is going on? It's freaking out on me. Okay, let's keep going. And then plus c. All right, so I'm forgetting that plus c again. Well, guys, if we know, now, so what we did, all we've done so far is we've taken the antiderivative of u cubed plus 1. Well, don't I know what u is, though? In this other equation, it says u is equal to x squared. Okay, so if u is equal to x squared, I could go ahead and replace u with x squared if I want to write this equation with x in it. So that's what we're saying here. Find each of the following antiderivatives in terms of x. This is the antiderivative in terms of u. So I need to rewrite that with x's in it. So now I'm going to substitute x squared in for u. So let's go ahead and do this. It's going to be x squared to the 4th over 4 plus x squared plus c. Do you guys see what I did there? All I did was I substituted x squared in for u. And now this is a function with x in it. Okay? Dang, going. I don't know what's happening. All right, so x, I'm just going to simplify, guys. One thing to simplify, x squared to the 4th. What do you do when you take an exponent to an exponent? What's the shortcut? Hopefully you said multiply, not add. You multiply those exponents together. So it's going to be x to the 8th over 4 plus x squared plus c. All right, so that is the integral of f of u du. Now this last one, I want to make some connections here. I want to kind of show you that there's a difference between f of u du and f of u dx. Okay, so let's do that next. Here's the last one. Dang, go on, come on. Stay. You stay. There we go. All right. Sorry, it sounded like I was talking to my dog. All right, here we go. Let's do this last one. We got the integral of f of u du. Well, again, we know what f of u is. All it means is we got to plug u in wherever we see x in the f function. So this is the same thing as the integral of u cubed plus 1, but this is telling me I want to integrate with respect to x. So dx. So right now, I don't have x's here. I can't integrate this until I get this to look like an equation with x in it. Okay, so I'm trying to show you that f of u dx, the integral of it, is different from f of u, I'm scared to do this here, f of u du. Okay, I'm trying to show you it's different here. So let's go ahead and try to integrate this. Well, we can't do it now because, again, this is telling us to integrate with respect to x, and all we have are u's. All we have are u's. Okay, we got u to the third. But now I could substitute, before I do any integrating or anti-differentiating, I could substitute in for u before I do integration. So that's what this means. Before I integrate, let's go ahead and replace u with x squared. Is that okay? So we know u is x squared, so therefore it's going to be the integral of x squared cubed plus 1 dx. So now, actually before I get started here, let me just simplify. So this is the integral from, sorry, we don't have an interval, but it's x squared cubed, which is x to the 6th plus 1 dx. All I did was I simplified there, and now I'm going to keep going. Okay. Here we go. So to keep this thing going, now I can actually integrate this because I've got a function with x in it, and I know I want to integrate with respect to x. So we can go ahead and integrate it. I'm going to take the antiderivative. So, same process. Whenever we have a polynomial function, all we got to do is add 1 to the exponent, divide by the new exponent. So when I add 1 to the exponent, it's x to the 7th over, well, 7 plus, again, if I have a constant, when I anti-differentiate, it's just going to be that constant times our variable. So it's going to be plus x and then plus c. All right, so notice the difference here. This is f of u du. So this means we integrate with respect to u and then plug in x squared. This right here is f of u dx. So that means we have to substitute first and then anti-differentiate. Okay? So that's the idea. Notice the difference. This guy right here is obviously different than that guy. Okay. Now, just want to do one more example before I stop this video. And I'm going to have you write one thing after this, okay? Debating on whether to write this fact down before or after. I'll do after. So here we go. Let's think about it first. Let's try to do this example first. Okay. Now, this is the first example of actually anti-differentiating using substitution, okay? So, I'm just going to warn you, it might not make sense. Everything I say right at the beginning might not make sense, okay? Stick with it, okay? What I'm saying is, stick with it. Hopefully it does by the end of this problem, and I'll try to be thorough here, okay? So if something doesn't make sense right away, just write it down, stick with it, and hopefully it'll make sense at the end, okay? And if it doesn't, we're going to keep doing practice problems on these. All right, that'll be other videos. Hopefully I can make some more videos here. All right, so we're going to evaluate the integral from sine x e to the cosine x plus, or sorry, not plus, dx. Okay. I know this looks complicated. So what I want to do here, just bear with me here. I'm going to introduce some variable. I need to make this easier. This looks pretty complicated, doesn't it? I'm trying to make things a little bit easier on myself. So what I'm going to do, I'm going to let some random variable u equal something in this expression. Okay? So we're going to let u equal, I'm going to let it equal cosine x. Now again, it might not make sense why I'm doing this. Hopefully you'll make some connections here. All right. So if we did let u equal cosine of x, before I do anything else, again, just bear with me. It might not make sense why I'm doing this. What if I wanted to find the derivative of both sides here? What if I wanted to take the derivative, not antiderivative, the derivative, okay, what we talked about in the first semester. We're going to work on finding the derivative here. Again, if this doesn't make sense, bear with me here. Okay, so if I want to take the derivative, let's just go with it. So the derivative here is going to be du dx. Doesn't that mean the derivative of u with respect to x? And that's going to equal, well, the derivative of cosine, if you remember, is negative sine. Negative sine x. Okay. So with that, let's keep this thing going here for a second. Again, bear with me. All right. But what if I pretend, I mean, this is kind of like a fraction, isn't it? du over dx. So what if I wanted to solve for du? Okay, just for fun, just for kicks and giggles here. All right. So what if we wanted to solve for du? Well, in order to undo division by dx, we got to do what? That's right, multiply by dx. Okay. So therefore, du is going to equal negative sine x dx. Okay. We're still working, guys. So that's what du is going to equal. Now, there's a reason I did that. Okay? So what I'm going to try to do is I'm going to try to rewrite this integral. I'm going to try to rewrite it with u's in there. I'm going to try, instead of writing it as f of x dx, which is what I have right here. This is f of x dx. I'm going to try to write it as f of u du. Okay? The reason for that is it's going to be a heck of a lot easier when I integrate that, if I can write it as f of u du. Okay, so let's go through that process here. So let's keep it going. All right, so stick with it. So I'm going to come back to what we just did up here. We're going to kind of shift gears. So I'm not going to forget about this stuff we worked on. All right, I'm going to shift gears, and now I'm going to rewrite this integral. So again, the integral that we have is the integral of sine x. I'm just rewriting it. E to the cosine x dx. And that is going to equal. Now, just answer this. Again, might not make sense why I'm writing this way. Isn't this the same thing as negative integral of negative sine x e to the cosine x dx? If that doesn't make sense, think about it this way. Isn't a positive the same thing as minus a negative? Okay. All right, so hopefully that's all right. Now, what I'm going to do from here is I'm just going to do a little bit of rearranging. Okay, let's rearrange some things. So we're still going to have this minus out here. So we have minus this integral. Now, I'm going to write it like this. Isn't multiplication commutative, guys? We got three things being multiplied. Negative sine x, e to the cosine x, and dx. Okay, those are all being multiplied. So I can write those in any order. All right, I'm choosing to do this for a reason here. I'll explain it in a second. So I'm going to rewrite this as e to the cosine x. And also, multiplication is associative, right? So we can put parentheses wherever we want. So it's going to be negative sine x dx. Okay. We're getting somewhere. Keep this going. So, again, just because I'm allowed to do this, that's what you need to understand. I'm allowed to do it. All right? That's all you need to know for right now. All right, I'll keep trying to explain this as we move on. All right, so now here's where I'm going to make the connection here. The reason why I did all this stuff. Okay? Still have this minus. I'm going to try to rewrite this. Instead of writing it as f of x dx, which is what my original is. This is a function with respect to x, dx. I'm going to try to write as a function with respect to u, du. Okay, so think about this. I'm going to rewrite cosine. Didn't we let, right up at the very top here, didn't we let u equal cosine x? So, since we let u equal cosine x, we can replace cosine x with u. So this is going to be e to the u. All right, guys, let's keep it going. Now, does this look familiar? Let me box this up. I'm pointing to this. Does that look familiar at all? It should. It is that's what du is equal to. Okay, so du is going to equal negative sine x dx. Okay? So, this whole thing, negative sine x dx, I can replace with du. Alright, so, all we got to do is, instead of writing this as e to the cosine x times parentheses negative sine x dx, we can write it as e to the u times du. And let me make that blue. Sorry, a little OCD. That's a heck of a lot easier to integrate now. Now we can go ahead and integrate this because we've got e to the variable u, and then du. So we want to integrate with respect to u. Okay, so we're almost there. So this is very easy to integrate now because we have formula page, but you guys shouldn't be able to remember this. The integral of e to the u. Guys, the derivative of e to the u is e to the u times du dx. So the antiderivative of e to the u is still going to be e to the u, but we're going to have a plus c. So it's going to be negative e to the u, and then plus c. Now you might be asking yourself, why did that du go away? Guys, this thing always goes away when we integrate. Okay, hopefully you've noticed that. It's always going to go away. All right, so that's the idea. So it's going to be negative e to the u plus c. Now, guys, you could write this a number of different ways. You could distribute the negative, but guys, a constant is a constant, whether it's negative or positive. I don't know what this constant is, so it doesn't matter whether I call this a minus c or a plus c. So I'm just going to rewrite it as negative e to the u plus c. And then I just got one more thing, guys. We want to write this with respect to x. So now that we've got the integral, we've got the antiderivative here, I'm going to replace u with what we let it equal at the beginning. Okay, so then we say u is equal to cosine x, and that's true. It's going to be negative e to the cosine x plus c. That right there, my friends, is my answer. Okay, so it doesn't matter whether c is positive or negative. It's a constant. So c could have been negative, could be positive. It doesn't really matter what sign we put on there. We don't know what that constant is. Okay? So, last thing. Let's just double check this. So guys, what we did is we took that original guy and we anti-differentiated. So a good way to check this is if you take the derivative of this guy. If we take the derivative of this, it should give us the antiderivative, or sorry, not the antiderivative, but it should give us our original function, what we have in here. So if I take the derivative of my antiderivative, it should give us what's inside here. Okay, so let's do that real quick. So let's try to roll through this. So with this, you got to use chain rule because you got a function inside a function. So remember, you have to take the derivative of the outside function, keeping the inside alone right away, and then multiply by the derivative of the inside function. So the outside function here is e to a power, or negative e to a power. So if we take negative e to a power, the derivative, then isn't that just negative e to that same power? Okay, so the derivative of the outside function is just what we have, negative e to the cosine x. But then we need to multiply by the derivative of the inside function. So the inside function is cosine x. So what is the derivative of cosine x, if you remember? Back to derivatives. Now remember, I said derivatives, not the antiderivative. So what is the derivative of cosine x? And the answer is negative sine x. So I'm taking the derivative of the outside function, so it pretty much stays the same because derivative of e to the u is e to the u. And then we got to multiply by the derivative of the inside function, which is negative sine x. And by the way, what's the derivative of a constant? So if this was 10, what's the derivative of that? It's 0. We don't need to worry about that. And so guys, what's a negative times a negative? Positive. And I can rearrange this. So this is the same thing as sine x times e to the cosine x. Isn't that what we started with? Look at that. Bingo. All right, good stuff. So I'm going to stop that video right here. I'm going to try to have another video for you where we do more examples.